Alright, so I think this is recording. This is not cooperating this evening. This software, it's being difficult to record these videos. So let's see. We're looking at skill packet, the review for skill packet 7. Here in problem number 18 and 19, they want me to identify what quadrant the terminal side of this angle lies in. Remember that an angle that's written in standard position has the initial side that coincides with the positive x-axis. So my 192, well, let's write our boundaries on here, angles for our quadrants. We've got, if any angle is between 0 degrees and 90 degrees, it's going to lie in quadrant 1. If you're bigger than 90 and smaller than 180, you're in quadrant 2. If you're bigger than 180 and smaller than 270, you're in quadrant 3. And you've made one complete revolution if you're up here at 360. So 192, positive angle measure is counterclockwise. So I rotate this direction counterclockwise, and my terminal side is here in quadrant 3. Because this is quadrant 1, this is quadrant 2, and this is quadrant 4. I don't know why they use Roman numerals, but it's just pretty standard. You don't, if you want to call it 1, 2, 3, and 4, that's fine. But that's what they wanted. That 192 degrees lies in quadrant 3. All right. So with radian measure, let's look at it. When we here in the previous problem, it was easy to make a comparison that 192 was bigger than 180 and smaller than 270. When you have fractions and you're trying to make those same comparisons, you want to get a common denominator, so then you can just compare the numerators. So even though in radian measure you're in quadrant 1 if you're between 0 radians and pi over 2 radians, you're in quadrant 2 if it's pi over 2 to pi. It's not cooperating. And if you're bigger than pi but smaller than 3 pi over 2, then you're here in quadrant 3. If you're bigger than 3 pi over 2 and smaller than 2 pi, then you're in quadrant 4. Now, also remember the idea of coterminal angles that have the same initial side and same terminal side. So if you have a whole list of coterminal angles, they all lie in the same quadrant if they're coterminal. So let's find the coterminal angle of 22 pi over 3 that's between 0 and 2 pi. Because I know that if I rewrite 2 pi with the denominator of 3, that 6 pi over 3, that 6 over 3 is 2, that this 22 is bigger than 6, that this has wrapped around several times, and I just want to know the angle that's between 0 and 2 pi so I can easily see what quadrant it's in. So if I start subtracting multiples of 6, what do I have? Well, I can do that real quick on a calculator so I don't make a silly mistake. I've got 22 minus 6, and that's not less than 6, and then minus 6, and I'm at 10, and then minus 6, and I'm at 4. So I claim that 22 pi over 3 and 4 pi over 3 are coterminal. And if they're coterminal, then their picture in standard position is the same. The initial side and the terminal side, I should say, are the same. So even though you're wrapping around it several times, here 22 pi over 3, 4 pi over 3 is between 0 and 2 pi. Now I want to make my comparison against these boundary angles. So what's the common denominator between 2 and 3 is 6. So I'm going to look at pi over 2 as 3 pi over 6. I'm going to look at pi as 6 pi over 6. I'm going to multiply this by 3 over 3 and get 9 pi over 6. Multiply this by 6 over 6 and get 12 pi over 6. Now, let's rewrite 4 pi over 3 with a denominator of 6 multiplying by 2 over 2. 4 times 2 is 8, and 2 times 3 is 6. So 8 is bigger than 6 but smaller than 9. So I know that 4 pi over 3 lies in quadrant 3, which is coterminal to this 22 pi over 3. So you would just have to wrap around it multiple times, to get there. But coterminal angles have the same initial side and same terminal side. So I know that 22 pi over 3 lies in quadrant 3.